The tale of a natural order protected by a guardian, who, becoming corrupted by an unwelcome guest, threatens the cycle of life and death. A number of events can cause cellular stress, including DNA damage, hypoxia, or damage by free radicals. When a cell becomes stressed, one end result can be apoptosis. Apoptosis is the naturally programmed and targeted cell death. It is critical during development and tightly regulated, as aberrations in apoptosis can impact cellular health and cause disease. Apoptosis is used to maintain homeostasis, balancing cellular division with cellular death. When apoptosis is downregulated, diseases of cellular accumulation can occur. Conversely, when cellular death outweighs cellular proliferation, degenerative diseases can occur. Apoptosis can be initiated by two separate pathways. The extrinsic pathway is stimulated by death receptors of the TNF receptor family. Our focus today, the intrinsic pathway, is initiated in response to non-receptor-mediated stimuli like DNA or cellular damage. Now let's take a deeper dive into this intrinsic pathway. P53 is a transcription factor. A transcription factor is a protein that goes along the DNA and turns on and off different genes by binding to promoter regions. Though the exact mechanism by which P53 leads to apoptosis is still being understood, the general idea is as follows. P53 binds to promoter regions that activate pro-apoptotic or anti-apoptotic proteins from the BCL2 family that act on the mitochondria. Important to apoptosis is the MOMP. No. The MOMP, or the mitochondrial outer membrane permeabilization. Anti-apoptotic BCL2 proteins will inhibit the MOMP. Pro-apoptotic BCL2 proteins can induce the MOMP, which leads to the release of cytochrome C into the cytosol. Cytochrome C is a hemoprotein that is part of the electron transport chain. Cytochrome C is a hemoprotein that is part of the electron transport. Cytochrome C is a hemoprotein that is part of the electron transport chain in mitochondria. The electron transport chain in mitochondria, helpful for making ATP. Anyway, in the cytosol, cytochrome C binds to the APAF1, which initiates the initiator capsases. Caspases. Caspases stand for cysteine aspartic proteases, cysteine aspartic or cysteine dependent aspartate directed proteases. The initiator caspases cleave and activate the executioner caspases, which begin to degrade cell components.
Let me tell you about formaldehyde. Formaldehyde is a colorless, flammable, strong-smelling chemical that is used in building materials and to produce many household products. It is used in pressed wood products such as particle board, plywood, and fingerboard, fiberboard, glues and adhesives, permanent pressed fabrics, paper product coatings, and certain insulation materials. In addition, formaldehyde is commonly used as an industrial fungicide, germicide, and disinfectant, as preservative in mortuaries and also in medical laboratories. Formaldehyde also occurs naturally in the environment. It is produced in a small amount by most living organisms as part of normal metabolic processes. At certain exposures and doses, formaldehyde can cause cancer.
It has been suggested that formaldehyde inhalation exposure can lead to changes in the epigenetic landscape. Specifically, it can result in changes of the regulators P53, such as miR125B. This can lead to a decreased expression of BAC1, a member of the BCL2 family. BAC1 is pro-apoptotic. A decreased expression in BAC1 will mean not so much apoptosis. Therefore, formaldehyde disrupts the natural cycle of cell proliferation and cell death. The result of too much proliferation can be cancer. Knowing that someone has been exposed to formaldehyde, doctors might one day be able to somehow increase the expression of things like BAC1 to keep the natural order of cell proliferation and cell death.